class today, we're starting the ionic compounds unit, and we're talking about the chemistry to memorize. This is the ionic bonds unit. I'm calling it a mini unit because ionic compounds, covalent compounds and covalent bonds, and balancing equations make one big super unit. So what we do is we do the ionic compounds mini unit, boom. We do the covalent compounds unit, boom. And then the balancing equations unit, boom. Each of the mini units have their own test. And then we have one big super test put together because all three units do go together to make one big super unit. It's the longest unit of chemistry. That's why we broke it into 3 chunks. So we're talking about chemistry that must be memorized. And so far, I've really stressed that you need to understand chemistry, be able to apply chemistry, that you really shouldn't memorize chemistry. You should really focus on understanding and application, because even if you did memorize it, it would change you, or you wouldn't be able to memorize every form of application. And that is true, except for what we're talking about in this very specific slideshow, which is chemistry that needs to be memorized. Because understanding these terms, understanding these roots, understanding these prefixes, understanding these ions and these polyatomics, and just memorizing them, knowing them backwards and forwards, will set every student up that really is successful in this for a really much more successful second half of chemistry, because then you won't have to keep referencing what they mean. You will just know. So when we're talking about when we're memorizing it, what do we have to memorize? Because it's a lot of information. I know it's a lot of information. You have to memorize the spelling. You have to memorize the proper capitalization of symbols, the placement of the charge, superscripts, subscripts, the proper Roman numerals, what they mean, how to show them, element forms of names, names to element forms. Note, this is all of the information that will be on a test. And this test will not allow periodic tables. Only on the information on this slide will be on the test, so study hard. This is the polyatomic chemistry to be memorized test. I am legitimately giving you all the questions and all the answer keys for the test. It is up to you to memorize them. Okay, so for these notes, I always recommend people take it in 2 colors. Because you're going to be getting like a term and like the meaning, or a term and the root, or a term and a name and an ion, and doing it in 2 colors will really help you organize your notes. I'm also suggesting that you make headers of my titles so that you can make sure your notes are organized. So let's get started. The first header that I would make is Greek prefixes. Your first header should be Greek prefixes, because the next 10 items that we're going to talk about are Greek prefixes. So I've made this handy chart. The slash means or. So you can either write the word 1 or the numeral 1. Please don't write 1/1. It means the same. So choose one format of showing it. So the prefix mono, that's M-O-N-O, means 1. The prefix di means 2. The prefix tri means 3. The prefix tetra means 4. And the prefix penta means 5. Okay, moving forward. The prefix hexa means 6. The prefix hepta means 7. The prefix octa means 8. The prefix nona or nona means 9. And the prefix deca means 10. So if we were to think back to kindergarten and we were talking about an octagon, octa literally means 8, so it's an 8-sided gon, or 8-sided figure. Hexagon, 6-sided figure. Pentagon, 6-sided figure. Nonagon, 9-sided figure. So we see these prefixes in places other than chemistry, so that they're really good to know, so that we know what we're talking about, and know that octagon isn't just some random word. It really means 8-sided figure. Octopus, octa means 8. So octopus has how many legs? 8. That's why knowing these prefixes are really nice. Okay, moving forward. Your next big title or your next header is common non-metallic roots. Common non-metallic roots. You will see me write both non-metallic and non-metal with both a hyphen and a non-hyphen. That's because I can't decide which one is correct. So if you're wondering why, I'd probably need to actually look it up on the internet so I do it correctly, but I have not done that yet. So your next header is common non-metallic roots. So on this one, you have a root, and do not worry about whether capitalization counts or does not count for the root. It doesn't, but capitalization does count for the symbols. So the root HYDR, that's hydr, goes with the symbol H, and it stands for hydrogen. The root carb, that's CARB, goes with carbon, and the chemical symbol is C. The root ox, OX, goes with O, and that is for oxygen. The root silic, SILIC, goes with SI, or silicon. The root sulf, SULF, goes with S, or sulfur. The root arsen, ARSEN, goes with AS, or arsenic. The root brom, BROM, goes with BR, or bromine. And the root iode, IOD, goes with I, or iodine. Okay, the next set of roots are niter, NITR, short for nitrogen, and the chemical symbol is N. Phosp, short for phosphorus, chemical symbol is P. The next one is chlor, short for chlorine, chemical symbol is Cl. Next is selen, SELEN, short for selenium, chemical symbol is Se. Next root is antimony, short for antimony, chemical symbol is Sb. The next root is bor, BOR, chemical symbol is B, short for boron. Okay, the next big header to write is common non-metallic ions. Common non-metallic ions. That's your next big header. These are also called common non-metal ions. Either way, non-metallic or non-metal ions. Okay. So the name sulfide goes with S with a charge of 2 minus. Remember, capitalization counts for the symbols and the charge must be superscript. And I recommend strongly that you write the charge as number and then your plus or minus. So number and then your plus and minus. So sulfide goes with 2 minus. Fluoride goes with F1 minus. Chloride goes with a Cl1 minus. Phosphide goes with P3 minus. Nitride goes with N3 minus. Arsenide goes with AS3 minus. And bromide goes with Br1 minus. Please notice for the names of these, it is the root of the element that we just did, sulf, fluor, phos, niter, arsen, brom, with the word "ide" at the end. Okay, your next set of these are hydride, H1 minus, iodide, I1 minus, oxide, O2 minus, selenide, Se2 minus, and antimonyide, Sb3 minus. Notice for antimonyide, it's not the antimony with a Y because the Y was right next to the I. The Y drops out and you just have Antimonide, antimonide with no Y, and it's Sb3 minus. Okay, the next big header are common metal ions. So the next big header is common metal ions. So here we go. I want to remind you of some things on this. For the name, there is no space between element and brackets. So the brackets are your round brackets, not your square brackets, and there is no space between element and brackets. The information in the brackets are Roman numerals, and you're using capital I's or capital V's, not lowercase l's. They are different, so you must use capital I's. Other than the Roman numerals, it does not matter whether names are capitalized or not capitalized. What does matter, as always, is the capitalization of chemical symbols and making sure the charge is superscript, the number, and then the charge, so 1 plus 2 plus 3 plus, and then making sure that you have any superscripts, superscript. So let's start. Copper 1 ion, and yes, you do have to write the word ion. So copper 1 ion is Cu 1 plus. Copper 2 ion is Cu 2 plus. Please note, look at this. Copper 1, you have 1 in Roman numerals and your charge is 1. Copper 2, you have 2 in Roman numerals and you have a 2 charge. The pattern holds. Iron 2 ion is Fe2 plus. Iron 3 ion is Fe3 plus. Mercury 1 ion is Hg2 2 plus. The 2 down below shows that there's 2 mercury ions. Mercury 2 ion is Hg2 plus, and the lead 2 ion is Pb2 plus. The mercury 1 ion one is a tricky one that you're really going to have to work to memorize. Okay, let's move forward. You have the lead 4 ion. IV is 4, and